All right, hi everybody, this is Miss Marcotte. I wanted to record a quick video about what we started talking about yesterday and today after the quiz you guys did on dividing fractions. This week we're going to continue talking about greatest common factor and get into least common multiple. So far this week we've talked about prime factorization, the difference between a prime and composite number, a prime only having exactly two factors. So for example, 5 is a prime number. The only numbers you can multiply to get 5 is 1 and 5. A composite number like the number 9, the only number, or 9 has more than two factors. So I can multiply 1 times 9 and get 9, but I can also multiply 3 times 3 and get 9. So that's why 9 is not a prime number. So we're going to go through some examples, how I can use the prime factorization, the factor tree, to help me find my greatest common factor between two different numbers. Okay, so first we're going to start out looking in your book on page 128. We're going to look at question number 21. If you saw, I posted the notes that we took yesterday and today. Some of the classes got to number 19 and 20 in the book, some of them didn't. So you can look at the PDF to see how we did number 19 and 20 together. But let's look at number 21. So for number 21, we're trying to find what is our GCF, our greatest common factor between the numbers 32 and 81. 32 and 81. So the first step we're going to do, we're going to create our factor tree for 32. So I'm thinking, what can I multiply to get 32 that's not 1 times 32? Because our goal here is to try to make it smaller. So a couple of different things here that you could use. You could use 2 times 16, or you could use 4 times 8. Let's do 2 times 16 here. It doesn't really matter which one you use. Either are going to work. Okay, so notice I've circled that 2 because that's a prime number. Okay, 16 is not a prime number. I need to continue to break it down. All right, so I could do 2 times 8, or I could do 4 times 4. Let's do 4 times 4. Neither of those are prime numbers, so I'm going to break them down even more. Remember, our goal here with the factor tree is we're trying to get all prime numbers at the bottom. We're trying to have all of our branches have little apples on them with circles. Okay, so to get 4 times 4, I can to get 4, I can multiply 2 times 2, and 2 is prime. So I'm going ahead and circling all of those. All right, so I'm done with 32. Let's look at 81. 81. All right, so you could do, I believe, 3 times 27, but let's just do 9 times 9. 9 times 9 gets me 81. 9 is not a prime number. I multiply 3 times 3 to get 9, and 3 is a prime number. All right, so I've circled all those 3's. All right, so now I'm ready to make my prime factorization. So for 32, I want to make sure that I get all of those 2. So I've got 2 times 2 times 2 times 2 times 2. I should have 5 2's there, because when I multiply 2 times 2, I get 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 gets me 32. So when I multiply all those 2's together, I get 32. All right, we do the same thing for 81. 3 times 3 times 3 times 3. Perfect. Okay, so our last step here would be to find common factors between 32 and 81. But 32 and 81 don't actually have a common factor. 32 is just all 2's, 81 is just all 3's. So actually the greatest common factor between 32 and 81 is just the number 1. 1 times 32 gets me 32. 1 times 81 gets me 1. So for example, if you had that as a fraction, 32 over 81, and you were asked to put that into simplest form, that is already in simplest form, because there's nothing, there's no number, there's no factor that I could divide both the top and bottom by to simplify it. Okay? So when you get to this step with the prime factorization and there's no common factor, your greatest common factor is 1. All right, so now let's try a word problem. So we're going to turn the page, look at page 130, and we're going to try number 42. All right, so Mr. Jenkins has 48 paintbrushes and 60 tubes of paint to put into cups. The greatest common factor for the number of paintbrushes and the number of tubes of paint is equal to the number of cups Mr. Jenkins has. Find the number of cups that Mr. Jenkins has. All right, so we see in there that our greatest common factor, it tells us the greatest common factor. So it kind of gives it to us. What are we trying to find here? We're trying to find out the greatest common factor. Greatest common factor for the number of paintbrushes and the number of tubes of paint is equal to the number of cups Mr. Jenkins has. So we have to find the greatest common factor between the paintbrushes and the tubes of paint, and that will give us our answer. So if I'm looking back through, I'm following my cube strategy, circling any key numbers or units. 48 is the number of paintbrushes, and 60 is my number of tubes of paint. So I need to find the greatest common factor. Oops. Try that again. My greatest common factor, GCF of 48 and 60. All right, so let's start with 48. And I actually think that was one that we did in class, so you could go back to your notes for that one. All right, what I can multiply to get 48, again, there's many different things I could pick. I could pick 2 times 24, 3 times 16, 4 times 12, but I believe in our notes we did 6 times 8. Neither of those are prime numbers, so I've got to keep going. For 6, I can do 2 times 3. Both of those are prime, so I can go ahead and circle those. 8 is not a prime number, so I can break that down to be 4 and 2. Again, I know 2 is a prime number. All right, not done. I still have that 4, which I multiplied 2 times 2. Now I'm finished with 48. All those branches have a circle on them. All right, let's do 60 now. Again, I could do 2 times 30. I could do 5 times 12. Let's do 2 times 30. All right. Again, it doesn't matter what you pick. It just has to be factors. 2 numbers multiplied together, that gets me 60. 2 is prime, so I go ahead and circle it. Let's break up 30. We could do 2 times 15. We could do 3 times 10. Let's do 6 times 5. All right, so here, 5 is a prime number. 6 is not. I've got to keep going with that. All right, so 2 is prime and 3 is prime. Awesome. All right, so let's go ahead and write out our prime factorizations. For 28, I had 1, 2, 3, 4 2s. So I've got 2 times 2 times 2 times 2 times 3. Notice I've done these in order from least to greatest. It is not just random. All right, let me go ahead and do 60. So for 60, I've got 2 times 2 times 3 times 5. All right, now I'm looking for common factors that they have. I'm looking for pairs. All right, I can see they've got 1 pair of 2, and they have a second pair of 2, and then they have they share a 3. Okay, and that's okay that those 3s are not on top of each other. We're just looking for common factors here. Okay, so notice we've got some leftovers. We're not doing anything with the leftovers right now. We're just putting them in the fridge. So for 48, we should have 2 2s left over, and for 60, we have a 5 left over. All right, so now to find my greatest common factor, we are going to multiply the common factors. And remember the example that I gave in class, I'm not going to be multiplying 2 times 2 times 2 times 2 times 3 times 3, right? You're thinking of a pair of shoes. I've got 2 pairs of shoes, but when I buy them, they come in 1 box. All right, so I'm taking 1 box of the 2s, multiplying it by another box of 2s, and then multiply it by a box of 3. All right, so I know that 2 times 2, that gets me 4. And I'm going to multiply that by 3, which gets me 12. So my greatest common factor between 48 and 60 is 12. And so that was equal to the number of cups that Mr. Jenkins has. So my answer should be A, 12 cups. My answer should be A, 12 cups. All right. Hopefully this was helpful. We're going to continue talking about greatest common factor tomorrow. And then on Thursday or Friday, depending on when you see me, we're going to talk about least common multiple. All right. Have a good night, guys. Bye.